This last example, in the last couple of years looking at the exam, I would say this last one is the most typical type of question that comes up on the exam. This one is going to have a hole, a vertical asymptote, and a horizontal asymptote. And that's the most typical type of exam question that comes up. So we go through the same thing as every other time. We factor completely. Bottom is a difference of squares. So step one, Step one, what are our non-permissible values? X can't equal -3, and x can't equal 3. What do we notice? Those factors are the same. So at -3, we're going to have a hole at -3 comma something. And at +3, we're going to have a vertical asymptote. So the factor that cancels out, that determines your hole. And a most common mistake, now you have to simplify this, and the most common mistake is that students just write y equals x minus 3. Why do they write y equals x minus 3? It's like, well, everything else cancels out. All I have left is an x minus 3. Why is that wrong? It's supposed to be 1 over x minus 3. Because the x minus 3 was in your denominator. It has to stay in your denominator. And when x plus 3 and x plus 3 simplify, okay, and some math teachers will say, a math teacher should never use the word cancels out, because that makes a student think that it goes away completely. Well, it simplifies to 1 over 1. And that's why there's still a 1 left up in top of our numerator. I'm going to put this equation in a box because every time you have a hole, you now have to graph the simplified version. You now can ignore the original equation completely because we've simplified it, and we now know it has a hole. In fact, we can say the coordinates of that hole by plugging in -3 into this equation, and we get 1 over -6. And now we have to graph what's left. And up till now, every question that we've had with a hole ended up being a line, which you could just graph easy, and quick, and be done. But now we have a rational graph that we have to graph. So we would have to go through steps 1, 2, 3, and 4 again. Now technically, we wouldn't have to redo 1, but I'm going to redo 1 just to show you what that means. If you were graphing this, what's your non-permissible value? And I'm changing color from blue to black, because now we're just talking about the blue equation of a 1 over x minus 3. What's our non-permissible value in 1 over x minus 3? X can't equal 3. And will it be a vertical asymptote or a hole? Well, it didn't cancel out. Now, the reason you don't have to do this step, because can you see that in our black step number 1, we did this already? We already knew that there was going to be a vertical asymptote at x equals 3. But if you were doing the blue graph right from the start, you would know that there's a vertical asymptote at x equals 3 as well. What does this graph look like? Well, we can start to graph it. X equals 3 is going to be our vertical asymptote. We also know that we have a hole at -3, 1 over -6. So we're going to graph the blue graph and just add the hole to it. In the blue graph, will we have a horizontal asymptote or oblique asymptote? The degree is the bigger on the bottom. That's going to be a horizontal asymptote. When the degree is bigger on the bottom, where is the horizontal asymptote? Always at y equals 0. So we can add that as well. Step 3. Step 3 is finding our x-intercepts and y-intercepts. Y-intercept is always the easiest. Plug in 0 for x. Can you see that when you plug in 0 for x, you'll get 1 over negative 3. To find our x-intercepts. Okay? We look at our blue graph, and we plug in 0 for y. And again, a fraction's only equal to 0 when the numerator is equal to 0. So when is 1 equal to 0? Is 1 ever equal to 0? No, you can't say I have one bank account and it has $0. No, that doesn't work. No, 1 is never equal to 0. So this one has no x-intercepts. And this is why we changed to blue. I changed my color coding to blue because once you have a 0, okay, that cancels out and you have a hole, you have to graph the simplified equation. Because the danger is you say, oh, I'll look at my original equation and I'll plug in 0 for y. Is my numerator ever equal to 0? Yes, at negative 3. And so you might think, I'll put in an x-intercept at negative 3. But that's not the case. Oh, that's not blue. Because negative 3 is a negative 3 is a hole. It is not an x-intercept. So we have enough points to draw this part of our graph. We do need to plug in an x value to find another point. And again, you'll plug that into your blue equation. And when you do that, when you plug in 4, you'll get 4, 1. So then you have enough information to sketch this part. And so, for a graph like this, this is the most typical type of graph that comes up on the final exam, where they have a hole, but they still have non-permissible values and horizontal asymptotes. And they could choose any graph that you've done so far and add this. So for example, if we go back to example 2. In example 2, if I started this equation with an extra x plus 3 on the top and an extra x plus 3 on the bottom, what would happen to those x plus 3's? They'd cancel out. But they'd cancel out and make a hole. Where would that hole be? Right there, at negative 3. And so the graph would be identical to the graph that we just made, but there would just be a hole added to it at negative 3. Does that make sense? So you can have any graph that you have and add a whole bunch of holes, right? I could add x plus 5 and x plus 5 and add another hole. Oh no, 5 doesn't work because that's already a non-permissible value. Let's go x plus 4 and x plus 4. And that would add another hole there. And then you go, oh, let's put an x on the top and the bottom. That would add another hole there. And you could add like 15 holes to a graph if you wanted to. But generally, they'll, like we saw in example 4, have your token hole in the graph, and then horizontal asymptote and vertical asymptote, and graph it completely. Unfortunately, in your homework, there's not a lot of these. So the questions you have to do are just 3, 4, and 5. And that's what we're going to do for the last 12 minutes. Don't be deceived by the time. It's late start, so we do go until 5 after.